Good afternoon, and welcome to the last education program for the 2021 MLPAA year. And even though we were not able to get together in person this year, we were able to have 5 outstanding educational programs. We're kicking off our MLPAA membership drive tonight, so please sign on to the MLP website, click on the Alumni Renew tab, and renew tonight after the program. Next year, if all goes well, we will be together again at our annual Welcome Back Social and Education programs in person. Speaking of programs, you will be receiving a survey within the next 2 weeks asking for your input on next year's program topics. All of our programs are determined by our membership, so please take 5 minutes and answer the survey. And now for the main event. Randy Baker, our program's chairman, will be your host and MC for tonight's program. Randy?
Thank you, Helen. I don't see myself, but I hope everyone else does. Our topic today is responding to climate change. Implicit within that title are at least 2 questions. The first is climate change real? And second, is it the next existential challenge? Many persons would answer no to each of those questions. Certainly our organization takes no position on them. However, because more than 90% of Earth scientists reportedly answer yes for purposes of our discussion, we will assume that climate change is a reality in the second part of our program. First, our principal speaker will review objectively the science behind climate change. Then for those who conclude the answer to the question is yes, or even probably yes, our speaker will present a climate solution simulator that can be used in one's home or office. This simulator will permit you to visualize the possible outcomes of different mitigation strategies on future greenhouse emissions. And a link to that free website will be provided in the evaluation form that we pass out tonight. Our speakers today are co-leaders of the San Antonio chapter of the Citizens Climate Lobby, a nonpartisan group dedicated to finding and helping to implement ways in which to limit our warming planet's mean temperature. Their objective is to keep the mean temperature below 2 degrees, the mean temperature warming below 2 degrees Celsius or 3.6 degrees Fahrenheit over the course of the next few decades. Our first speaker will be Dr. Stuart J. Birnbaum, an emeritus professor in the Department of Geological Sciences at UT San Antonio. As a member of that faculty, Dr. Birnbaum conducted research in sedimentology and microbial geochemistry. He earned his BS degree in geology from the State University at Stony Brook and his PhD from Cambridge University in the United Kingdom. In his retired life, Dr. Birnbaum is active in numerous environmental organizations and is a board member of the Trinity Glen Rose Groundwater Conservation District. Our second speaker is one of our own, Bill Hurley, a graduate of Class 6 of the Master's Leadership Program and a firm advocate for the environment since his retirement. He became a CCL group leader in 2016. He holds a degree in information systems from Our Lady of the Lake University.
So the title of the talk, as Randy presented it, is Responding to Climate Change, the Next Existential Crisis. And I would like to thank everyone for taking the time to be here tonight to explore this extremely important topic. As Randy said, please put any questions that you might have in the chat, and we'll address them a little later on at the end of the presentation. Little overview of what we'll be doing this evening. First, we'll explore some of the background to climate science, what we know, and appreciate this is going to be a thumbnail sketch of the data. Then we'll look at what's at stake if we do nothing. And doing nothing is kind of a misnomer. The term that's used is business as usual. If we continue along the path that we have been conducting, and we are not doing anything, we're just doing little. Then I'll introduce En-ROADS. Very quickly, En-ROADS was developed at MIT Sloan School of Sustainability. It's a climate solutions simulator. When we get to that part of the talk, I'll give you a little bit more background. After we've explored some of these solution possibilities, we'll come back and look at the takeaways, what the implications are. Then I'll pass the baton to Bill, who will introduce you to Citizens Climate Lobby and legislation that we support. And then we'll end with questions and answers. So climate change. Let's very quickly review the science and what's at stake. We've all heard the term greenhouse effect, and it's a term that everyone is kind of familiar with. But this diagram does a pretty decent job of explaining what happens. The sun emits energy across the entire electromagnetic spectrum. When it reaches our atmosphere, some of it is absorbed in the upper atmosphere. For example, ozone absorbs ultraviolet radiation. Ultraviolet is a very short wavelength. The longer wavelengths pass through the atmosphere to reach the surface. That then heats the surface. If you've ever stood next to a building in August, you could feel the heat coming off that building. Well, that's what happens. The Earth re-radiates that heat out, and it radiates it at a slightly longer wavelength. So the atmosphere is transparent for the incoming energy, but it's not perfectly transparent for the exiting energy. As a result, some of that heat is trapped in the atmosphere, and that's called the greenhouse effect. And it happens because of the differing wavelength between what reaches the surface and what's radiated back out. There are three primary gases in the atmosphere that absorb that energy: carbon dioxide, methane, and water vapor. Carbon dioxide right now is the gas we're interested in. And this chart shows the record of carbon dioxide from 800,000 years ago to the present. This dashed line is 300 parts per million. A percent is parts per 100. So parts per million is hundredths of a percent. And what we see is that there's a natural variability over time in the amount of carbon dioxide in the atmosphere, but it has never exceeded 300 parts per million until post-World War II. And in a very, very short period of time, the amount of carbon dioxide in the atmosphere shot up. It's now 417 parts per million and climbing. But is there a relationship between that and temperature? So first, let's look at temperature. Here we have a chart that shows temperature anomalies. On the left, it's the deviation from an average. The baseline average is taken between the years of 1951 and 1980, and that's this zero line. If it's cooler than that average, it's below that line. And if it's warmer, it's above the line. And you can see, again, this natural variability until about the 1970s, when that anomaly started climbing significantly. We are now a little over 1 degree Celsius. That's almost 2 degrees Fahrenheit. 1 degree Celsius is 1.8 degrees Fahrenheit. So we're almost 2 degrees Fahrenheit above that average. But is there a relationship between carbon dioxide and temperature? And that's this next graph. Oops. So on the left-hand side, we could see temperature change from the present. And along the bottom, we could see, again, that 800,000 years to the present. And on the right-hand side, the concentration of carbon dioxide. And what we can see, temperature in pale blue, carbon dioxide in dark blue. And you'll notice that they track right on top of each other. When carbon dioxide goes up, temperature goes up. Carbon dioxide goes down, temperature goes down. So it's really, for the science, unequivocal that there's a direct link between carbon dioxide concentrations and atmospheric temperature. And that's because of the relationship of carbon dioxide and the long wavelength infrared energy that is re-radiated out from the planet. If we did not have that carbon dioxide in the atmosphere, our planet would be frigid. It would be like Mars. Our temperature would be, instead of a average 25 degrees Celsius, it would be -5 degrees or 0 degrees Celsius. Water would be solid ice. Life could not survive. We would be a very different planet. So having that greenhouse effect is critical. The problem is we've been adding carbon dioxide to the atmosphere. So the sources of carbon dioxide emissions, this is from 1860 to 2016. This is the carbon dioxide emissions in gigatons of carbon dioxide per year. A gigaton is 1 billion tons. That's a whole lot of carbon dioxide. And later on, if people want me to give you an analogy of what 1 billion is, I'll explain what I would always do in class for my students. And of course, we have time running along the bottom. And we can see coal in brown, oil in black, natural gas in blue. These are the fossil fuels, and these are the primary sources of carbon dioxide. In pale brown or tan, we have land use change. Land use has to do with agricultural use and deforestation. And then in gray, we have others, and others include things like chlorofluorocarbons and nitrous oxide associated with agriculture and farming, agriculture and manufacturing. But you'll notice that land use has been fairly consistent. What has really grown is fossil fuel use. So let's look at greenhouse gas emissions by economic sector. On the left-hand side, we have global greenhouse gas emissions. On the right-hand side, we have United States. And if we look at, for example, electricity production, 25% globally, 27% in the United States, very similar. If we look at industry, 21% globally, 22% United States, very similar. Where the differences really ring out, globally, transportation is about 14% of greenhouse gas emissions. It's double that in the United States. Agriculture globally is about 24%. It's less than half that in the United States. So in some sectors, we're doing really well. In others, like transportation, not so well. Another important greenhouse gas is methane. Methane is between, let me make sure I got these numbers, between 28 and 84 times more potent than carbon dioxide. And the reason for that range is not that we do not know precisely. It has to do with the duration of methane in the atmosphere. Carbon dioxide remains in the atmosphere literally hundreds of thousands of years. Methane, when it's introduced to the atmosphere, degrades relatively quickly. So in the first 20 years, methane has the greatest global warming potential, and that's about 84 times that of carbon dioxide. But over a 100-year span, as the methane degrades, decomposes, it comes out to about 28 times more potent over that 100-year period. 28 times is still a significant impact. So what are our methane sources? Well, most of it comes from natural gas and petroleum systems, flaring, leaking oil wells, poor sanitation in production of oil and gas. Another major component is from enteric fermentation. Essentially, cattle and lambs, or sheep, they belch out methane, copious quantities. The third most impactful are landfills. As organic material decomposes in a landfill, methane is produced by methanogenic bacteria. These are microorganisms that produce methane. And again, the landfills aren't capped. They're not treated in a way to capture that methane on a large scale, so the methane escapes into the atmosphere. And then coal mining and decomposition of manure are the other big slices of the pie. Well, we're all familiar with the Paris Accords. In 2015, countries from around the world got together and said, we agree to voluntarily, this has no teeth in it, voluntarily keep temperature rise by 2100 below 2 degrees Celsius with a preferable target of 1.5 degrees. Well, how are we doing? Sadly, not very well. We are on target to reach a 4 degrees Celsius temperature rise. That's a 7.2 degrees, a little over 7 degrees Fahrenheit. What would happen with the business as usual scenario? What happens if we reach 4 degrees Celsius by 2100? Well, initially, over a period of 50 to 150 years, we're going to see a multi-meter sea level rise, perhaps 10 feet, 3 meters. There's going to be a widespread increase in the frequency and the duration of droughts, perhaps 60% increase. Mediterranean Europe will be subjected to these droughts and we'll start seeing deserts forming. There will be intense and frequent heat waves and intense and frequent flooding, especially in coastal regions, also associated with increased precipitation. That's the short term. The long term will see a committed warming. It's important to appreciate that our climate system has a lot of inertia built into it. The analogy might be like turning an aircraft carrier. You just can't turn an aircraft carrier on a dime. It takes a long time for that large beast to turn. Well, that's like our climate system. So once we've started down this path, we're going to continue down that path until nature equilibrates. So we'll have committed warming that will last centuries to millennia of perhaps greater than 6 degrees Celsius. That's about 11 degrees Fahrenheit. Long-term equilibrium sea levels, again, over millennia, will be 13 to 15 meters. That's 50 feet of rising seas. Melting of more than 2/3 of the glaciers in the Hindu Kush Himalaya. That is the freshwater supply for a couple of billion people. And irreversible change. This is truly an ecosystem tragedy waiting to happen. So business as usual, 4 degrees. Let's see what the coast looks like in our precious Gulf Coast here. This is today. This is with a 4 degrees Celsius, 7 degree Fahrenheit temperature rise. New Orleans is gone. Port Arthur is gone. Our Padre Island, Texas coast is gone. Here's Wall Street today. There's Wall Street with a 4 degrees temperature rise. Here's the horns of the bull. Well, actually, that's the tail of the bull. We're all familiar with the fires that have occurred in California the last few summers and the incredible fires in Australia. Australia, which is now parts of New South Wales, I believe, has experienced historic flooding. Climate-related disasters have cost the world $650 billion between 2016 and 2018. And damages associated with global warming could possibly total $54 trillion by 2040, according to a United Nations panel. Let's look at California very quickly. This is a chart that was just tweeted out by CAL FIRE, the state fire agency, about a month ago. This is the 20 largest California wildfires. The size of the slice, the size of that pie slice indicates the size of that fire. In black to gray, we have 1932 to 1999, a period of 67 years. In blue, we go from 2000 to 2019, a period of 20 years. And in reds is just 2020 alone. What we can see that in the 67-year period between 1932 and 1999, there were just 3 large fires. Between 2000 and 2019, there were 12. And in 2020 alone, there were an additional 5, all of which were as large or significantly larger than in the previous 88 years. What if, no, I'm not going to say what if, when we are successful, positive thinking here, when we are successful, what will our lives look like at 1.5 degrees of warming? Well, as I said earlier, we've caused about 1 degree of warming already. And I'm, again, referring to Celsius, it's 1.8 degrees Fahrenheit, above pre-industrial levels. It is necessary, indeed, it is vital that we maintain temperatures below 1.5 degrees. And the reason for that is that adaptation will be less difficult. It'll be easier for us to adapt. The world will suffer less negative impact from the intensity and frequency of extreme events. There'll be less negative impact on ecosystems, on resources, on biodiversity, food security. Everything will be easier to manage. This next slide shows what some of these impacts might be. So to give you an indication of what the color scale means, white over here on the right-hand side, this is a legend, no detectable impact. As we transcend through yellow, orange, red, and magenta, the impact becomes more and more severe, more and more negative. So here we are at 1 degree. Well, dry land water scarcity. That's a fancy way of saying drought. We're already experiencing that. Soil erosion. We're getting to that point where we're losing more soil. And if someone wants to know what the relationship is, put the question in chat and we'll come back to it. Vegetation loss. Plants aren't adapted to the heat. My wife and I, we used to live in Michigan. We're avid gardeners. When we came down to Texas, it was gardening in a whole new different world. The heat makes a difference. Wildfire damage. Well, we're already experiencing that. Permafrost degradation. And I want to come back to this a little later because that is a critical component to where we may end up. Tropical crop yield decline. We're already experiencing that. And food supply instabilities. At 1.5 degrees, we're in the detectable impacts. We're in the yellow across the board, transitioning into this orange and red for wildfires and permafrost damage, and definitely impacting food supplies. At 2 degrees, we're going to be hurting. We can survive, we can adapt, we can manage, but it's going to be costly. Not only monetarily costly, it's going to be costly to lives. So the title, Responding to Climate Change, the Next Existential Crisis, ? Well, I'll leave it to you to answer this question for yourself, but it should be clear that both Bill Hurley and myself, the answer is an unequivocal yes. The science is clear. We need to act. So in order for us to stay below 1.5 degrees Celsius, the science suggests that the world will need to reach net zero emissions on a timeline. Carbon dioxide must reach net zero by 2050. And this is for scenarios with little or no overshoot. So what overshoot might mean is 1.55, 1.6 degrees. But we want to keep close to that 1.5. Total greenhouse gas emissions, that includes methane. We'll talk about nitrous oxide and fluorocarbons. Those must be net zero somewhere between 2063 and 2068. We have a little larger window for that because they're much lower abundance. So this is what it looks like kind of graphically. Must reach for 1.5 degrees net zero carbon dioxide by about 2050. Total greenhouse gas 2063 to 2068. For 2 degrees Celsius, we have to reach net zero about 2077 with a bracket there. And net zero total greenhouse gases about 2089, 2090. So what is the problem that we face? Something that's been referred to as bathtub dynamics by John Stearman at MIT, one of the developers of En-ROADS. If we think of our atmosphere as a bathtub that's filled with carbon dioxide, some of that carbon dioxide is constantly being removed. Plants photosynthesize and remove carbon dioxide. There are natural processes. The weathering of rocks removes carbon dioxide. But here we are with a tap full open, carbon dioxide being added to the atmosphere. We cannot remove carbon dioxide efficiently and quickly enough as long as that tap is flowing and fully open. So we have to stabilize atmospheric greenhouse gas levels in order to get a substantial drop in global emissions. If we could reduce global emissions, we could stabilize the concentrations in the atmosphere, we could slow the temperature increase, moderate sea level rise, and ameliorate many of the other risks that I've already described. So that's what we're going to do. We're going to explore that. And we're going to use this tool called En-ROADS. En-ROADS was developed at MIT in the Sloan School of Sustainability. And it is hosted by Climate Interactive. Climate Interactive is a nonprofit entity that was created by MIT. En-ROAD stands for Energy, Rapid Overview, and Decision Support. It allows us to explore various scenarios for addressing the climate crisis. And this is the interface we'll be looking at. This is the interface we'll be using. I'm not going to spend much time on here because we'll actually be using it. But we have an area where energy supply, so coal, renewables, nuclear. We have areas where we could potentially reduce our dependence, improving energy efficiency in transportation or electrification of vehicles. Same thing in buildings and industry, electrify or energy efficiency. Land use, we can slow deforestation. We can reduce methane leaking. And then carbon removal, either through afforestation, planting trees, or technical removal, carbon capture. We're going to explore some of these as we go forward. But En-ROADS is powered by the latest research on climate change. It's a great tool for people to learn about how to assess the impacts of these different approaches. It allows you to create your own scenarios. This is free, open source, available for everyone to use. As Randy said, you'll get a link to this and go ahead and use it. It's transparent. All the equations and the model assumptions are open source, and it's dynamic. It responds to you instantly. But I guess the question is, why should we trust En-ROADS? Is this just another, ivory tower creation that is not based in reality? Well, I assure you it is not that. First of all, it's peer reviewed. All parameters and equations are published. The comparison of behavior is measured to historical data. This is what's referred to as backward-looking validation. And the way this works is we would imagine that we're, let's say, 1950. And we would say, well, if we're in 1950, these are the conditions that existed. We know what the conditions were. And we would model forward to, let's say, the year 2000 or even 2020 using En-ROADS and then compare it to what actually happened. And what we see is that, hey, this works. It actually works. And then finally, there's a comparison to other models referred to as integrated assessment models. These are models, these IAMs, the integrated assessment models. I apologize if I use an acronym, slap me out of it, but these integrated assessment models run on supercomputers and take days for the forecast to be, solutions to be presented. And En-ROADS is calibrated against 5 different integrated assessment models. All right, so I'm going to take us to En-ROADS, I hope. I am hoping that you can see En-ROADS. Oops, here I go again. I'm hoping you can see En-ROADS. Someone who's not muted can let me know if you can't. Over here on the left-hand chart, we have global sources of primary energy. And on the right-hand chart, I'm sorry, did someone say something? I'll assume not. On the right-hand chart, excuse me, we have greenhouse gas net emissions. And over here, on the extreme right, we have the temperature rise in degrees Celsius and degrees Fahrenheit. So the business as usual model is a 3.6 degree, not a 4 degree, a 3.6 degree Celsius temperature rise or a 6.6 degree Fahrenheit rise. Normally when I run one of these En-ROADS workshops, it's with smaller groups and it's interactive. And I would ask you, well, which of these do we want to explore? But in preparation for this and in conversation with Randy, it was decided that I would drive. So I'm going to drive. You may have read in the New York Times this morning and also in our San Antonio Express News, there were articles about Biden's infrastructure plan. And one of the key components of that was to stimulate the electrification of our transportation fleet, cars, trucks, buses, and the building of charging stations, 500,000 charging stations. So this is where at this point in time, I would say, well, here we have transport electrification. Oh, and I have to interject here. En-ROADS is a global model. This is based on every single country in the world doing this. This is not just the United States electrifying its fleet. This is everyone. So normally what I would do is say, well, what do you think is going to happen? Is there going to be a significant change? A little change? So here's what I want to do. When I move this slider, we're going to see this black line, which is business as usual, and that blue line. And the blue line is going to shift. Because if we go to electric vehicles, then yes, we will be reducing greenhouse gas emissions. Temperature will decrease. But I also want you to focus somewhat on the left-hand side, our primary energy sources. And let me tell you what the color code here. So coal is in brown. That's this line up here. Oil in this kind of orangey red color. On my screen, it looks like the UT orange, the burnt orange. Gas, natural gas is this darker blue. Renewables, green. Bioenergy, pink. Nuclear is this very pale blue down here. And new zero carbon emitting technology, a new zero carbon emitting energy source. And we don't know what that is yet. We're hopeful that technology will come up with some new approaches. So let's electrify the global transportation fleet. So I'm going to replay that. Watch what happens to temperature. There's a negligible change. It goes down 0.2 of a degree Fahrenheit. I'm going to replay this again, and I want you to focus your attention on these global sources of primary energy, particularly this brown line, coal, this red line, oil, and the green, renewables. So what happened? Oil went down quite a bit. If we're driving electric vehicles, we're not queuing up at the gas station to put oil, gasoline in our cars. Renewables went up. That's nice and predictable. But coal went up. Electrifying our fleet is only useful if our source of electricity is from green energy rather than fossil fuels. And that's another thing that's in the newly proposed infrastructure plan, to have a green electrical supply system by 2030 or 2035. I'm going to go back to PowerPoint for a second. I hope. Ooh, I passed it. So this is from the Energy Information Agency. And it allows us to explore which type of vehicle is most kind to our atmosphere, emits the least greenhouse gas emissions. And it's based upon the source of energy in that state. So here, we'll start with Texas. Natural gas is blue, wind energy here in black, coal in green, nuclear in this brown, and solar, a thin slice of solar in this pale blue. You'll notice that an all-electric vehicle has the fewest emissions, followed by a plug-in hybrid, and a gasoline engine car. Well, let's look at Wyoming. Here, Wyoming is this huge Pac-Man-like slice, which is generated by coal. 81% of Wyoming's electricity comes from coal. And then another 12.5% from wind. So an all-electric vehicle is not as emission-free in Wyoming because the electricity comes from a fossil fuel source. In fact, a plain hybrid, not even a plug-in hybrid, a plain hybrid is more efficient with respect to greenhouse gas emissions because it's not relying on that electric grid, which is produced by coal. And then here we have, all of these are less damaging with respect to greenhouse gases than a gasoline engine. Let's look at Vermont. Vermont gets all its electricity from green energy sources. Almost 58% from hydro, 18% from biomass, 16% from wind, and 8% from solar. So there are no net emissions from an electric vehicle in Vermont. So the source of that electricity is critical if we're going to have an impact by electrifying our transportation fleet. If we continue to use the sources we have, all you end up with is a fun car to drive. I've got an electric vehicle. I have a Nissan Leaf, and it is the most fun car I've ever had to drive, and it's dead silent. I could actually hear my wife talking to me instead of having to shout. All right, I'm going to return our, remember we have to get down to 2 degrees or better. Let's look at renewables. Let's crank up renewables. Not as impactful as you would imagine. Let's look at, one of the things that has been in the press over the past couple of years is the Trillion Trees project. Let's plant 1 trillion trees. Well, I hate to say, that's not particularly impactful at all. So, well, what if we plant trees, but also stop cutting them down? The combination helps. Methane. Let's reduce methane. Oh, that has a big impact. Remember, methane has a much higher 20 to 80 times greater global warming potential than carbon dioxide. So methane helps a lot. I think the point you could probably see here is that none of these alone will address the problem. There's one I want to focus on, and that's carbon price. If we put a price on carbon, it will not get us to 2 degrees. but it is the single most impactful approach. And Bill will talk a little later about a proposal that Citizens Climate Lobby has for a carbon price. So what I'm going to do is show you that we can indeed get below 2 degrees. So we're going to increase the energy efficiency of transportation. So we'll get more miles per gallon. We're going to increase the number of electric vehicles on the road. We're going to do something about methane. We're going to plant a lot of trees and stop cutting trees down. And we're going to put a price on carbon. What else can we do? Building efficiency. There is money in the proposed infrastructure bill to renovate and make more efficient buildings. We can electrify these buildings. We're below 2 degrees. We haven't looked at technological approaches. We haven't looked at carbon removal. And I think the science is telling us that in reality, we cannot do what needs to be done without some carbon removal, some significant amounts of carbon removal, whether that's done by planting more plants, more trees, whether it's done by enriching soil vitality, or whether it's done by technological carbon capture. All of that has to come into play. So let's do that. Oops. So we are now at 1.5 degrees, and we've gotten net zero at 2066. It is really difficult to get to net zero by 2050. It is doable, but difficult. So I'm going to go back to our, let's see, PowerPoint and try to finish up quickly so I could pass this to Bill. So what can we say in summary? Well, first, there's no silver bullet. To achieve 2 degrees requires what Climate Interactive likes to refer to as silver buckshot. We have to do many different things, and we have to do them well. The highest leverage outcome is keeping fossil fuels in the ground. And the best way to do that is putting a price on carbon, because it changes the fuel mix and it reduces energy demand. There are significant co-benefits for addressing the climate crisis. By keeping fossil fuels in the ground, there are significant health benefits. The World Health Organization calculated that the health benefits far outweigh the cost of meeting the climate challenge on its own. There are reports on clean energy and health that examine the collective impact of existing wind energy in the United States between 2007, when there was almost no renewables, to 2015, when the market just grew exponentially. They found that there were 7,000 fewer premature deaths. $56 billion was saved from public health benefits, and $32 billion was saved in avoided climate costs. Switching over to green energy will create lots of jobs. If $200 billion was invested every year in energy efficiency and clean energy in the United States, 4.2 million jobs would be created by 2030, and the 2030 unemployment rate would be reduced by 1.5 percentage points. And if a carbon tax is enacted as part of this plan, it would be revenue neutral. other benefits of climate action. We would prevent 295,000 premature deaths from air pollution. We would prevent 29,000 emergency room visits per year for childhood asthma, and that contributes to 15 million adult hours of lost work. And that's because fossil fuel use produces particulates, sulfur dioxide, other pollutants that aggravate asthma. Diseases and pathogens spread more slowly in colder climates with less flooding. And it would incentivize the development of new technologies. The cost savings from monetized health benefits would be about $800 billion per year for clean power and $400 billion per year for clean transportation, a total savings of about $1.2 trillion per year. So I'm going to end here. I'd like to hand this over to Bill. I'm going to stop the share.
Thanks, Stuart. Can everybody see the logo here for the screen? Yes, okay, and you can hear me fine, I guess. I'm seeing Stuart's head nod. I want to thank Stuart for showing us En-ROADS tool. I've seen it before, but it's every time it's immensely valuable and it's really very interesting. There's a lot out there already, and I personally remain hopeful that more, especially about more innovations. I just finished the book by Bill Gates, and that was a fascinating book. But the Citizen Climate Lobby promotes using carbon pricing to bring the market-based factors to bear that he was just describing. Basically, CCL is a grassroots organization that builds political will by training and supporting the volunteers. We're trying to build relationships with key stakeholders, policymakers, and the general public. There's really two halves to this organization. The first half is the lobbying itself. It's a 501c4, and the second half is the education segment, which is pretty profound. It's a pretty big deal that trains us volunteers how to interact with these people that I just mentioned. And both are nonpartisan, both began in 2007. As to the funding, this year's budget is over $900,000. The precise breakdown varies from year to year, but on average, 63% of the operating income is from people like you and me. And about a third of the income is from foundations. And of course, there's a little left over. That's from our regular conferences. That comes from 2 national conferences, one in the summer, one in the fall, and 1 regional conference in our region. CCL itself has grown quite a bit since 2007. Today, it's over 600 worldwide chapters. As you can see on the map, the United States has the majority of them. 458 chapters are in the US, and that covers 90% of all the congressional districts. Just in Texas, there's 24 chapters. Austin has 2, Dallas has 3, San Antonio and Houston have just 1. So what do? We lobby. We lobby in DC. We lobby locally. Each Congress district has a liaison person from us and a team of volunteers, usually constituents. That's where we get the most bang for our buck. Like me, I'm in District 21, Chip Roy's district, and we have just over 10 constituent volunteers that have met with staff maybe 4 or 5 times so far. And of course, what we're doing these days is using Zoom. We set this up for each of the 5 districts since San Antonio is so gerrymandered. That's the best way to do. And Zoom is really a godsend for this kind of stuff. So mostly in these meetings, we're promoting carbon pricing. And I want to point out here, I just got this on the mail today. American Petroleum Institute has come out with a paper finally saying that, quote, an economy-wide government carbon price policy is the most impactful and transparent ways to achieve meaningful progress. Maybe they have En-ROADS, I don't know. Anyway, we at CCL, we also specify a particular plan, the carbon fee and dividend plan we have for years. Number one, the money is collected as a carbon fee at the well site. Then two, it's allocated in equal shares every month to each taxpayer. Bill Gates gets the same as I get. And three, and oh, by the way, it's revenue neutral, so the government doesn't keep any of that money. It all goes back 100% to the taxpayers. And three, to keep other countries honest about climate action, there's a border adjustment process that affects both imports and exports. So in the current 117 Congress, Dick Durbin, the majority whip of the Senate, he's introduced in March, he introduced the America's Clean Future Fund Act. Up until then, there was no carbon pricing, as far as I know, in either house. But it's this plan is very close to carbon fee and dividend. It starts at $25 a metric ton and increases $10 each year, $35 next year, $45 the year after that. And 75% of that total income goes back to the low and medium income households quarterly. But wait, Stuart mentioned this. We just heard today that the Energy Innovation and Carbon Dividend Act, which we've been promoting for quite a long time, has been reintroduced. And it's got on the website, it's been updated. It falls in line exactly with what our CCL's plan was. It starts at $15 a ton and the first year, and it increases $10 a year after that, just like the other one. But 100% of the money goes back to the taxpayers, and it's sent monthly rather than quarterly. You know, details. But more details about it can be found at the energyinnovationact.org. I'll put the address in the chat. And if you go there, you can try this really useful calculator that I've circled here. This is a print screen of it. It's a very good app, and you can estimate how much you might expect back monthly. Anyway, this is really interesting in that both houses of Congress now seem to be jumping on board the carbon pricing idea. It's a big deal. The first one that I showed you was the Senate, and this is in the House. I almost want to stop here because the news on the energy innovation bill is so huge for CCL. But as our efforts have always been for federal actions, I must mention that locally in San Antonio, many of you probably know this, the city has acted too. The Climate Ready program, it started in 2017, and you can get more about those plans for San Antonio and its current status by checking out the Office of Sustainability website. Hopefully in our Q&A, you can get other answers that are needed, but we ask that you please check us out on the web at citizenclimatelobby.org.
Assuming all vehicles are electric in the United States by 2040, what would be the cumulative impact on CO2?
It's dependent entirely on the source of that electricity. So I have, as I said, an electric vehicle, but I also have, 30, between my house and community solar, close to 60 solar panels. So I charge my car off the sun. But the state of Texas doesn't have a pure green energy source. So the impact by 2040, if everyone were driving an electric vehicle and we continue to produce electricity using fossil fuels, is negligible. If the electric grid is cleaned up, as has been proposed, then it will have an impact. But we also need to make sure that long-haul transport, trucks, freight trucks, buses are also electrified. You're muted, Randy.
Don't know how that happened. The next question is, population growth seems to be a primary driver of all other issues. Are there efforts to slow or to stop population growth internationally?
Boy, I'd like to answer that, Stuart, if I could. That's a really good question. I think I've been involved in the environment since the mid 80s. And seems like every environmental problem, if you chase it down to its roots, is based in population. And since the Industrial Revolution, our population, when I was born in 1951, it was 3 billion people in the world, and now there's almost 7.5 billion. So yes, and each one of those people, not each one, but the developing world has each one of those people using like 30 times the resources we used to use. So yeah, that's the cause of how we got here in the first place. However, I don't think it's the solution that you can look at population as in any kind of way, like abortion or birth control or war or something like that. It scares people, and you don't have to go that way. We can just adapt without the population increasing. Now, that's my personal opinion, but I challenge anybody to. No, I think that's answers that question. This
Thank
is
you.
one of those things.
The next question is from Alexander Miller, and he asks, a big issue with renewables is inability to store their energy. What is the status of batteries or other energy storage mechanisms at economical and scalable levels?
Oh, that's a great question. I agree. Storage is critical. Battery technology is improving and costs are coming down. For example, solid state batteries are going to be released for transportation for cars within the next 2 to 3 years. They have a higher energy density than the lithium ion batteries that we use now, and certainly way more than the lead acid batteries. This is one of those issues. I want to talk about hydrogen because it's actually related to this. This is one of those issues where something like a price on carbon plays a significant role. If we remove subsidies from green energy and we remove subsidies, which are significant for fossil fuels, and put a price on carbon, an ever rising price, as Bill described, very quickly, these alternate technologies that appeared to be extremely expensive just a short while ago become competitive. So the high price of battery technology kind of disappears as the cost of fossil fuels or greenhouse gas emitting energy sources rises. But one of the things we should be doing, and it is being done on small scale activities, one of the things we could be doing is using excess wind and solar energy for generating hydrogen, what's referred to as green hydrogen. Hydrogen has a very high energy density. It's the type of fuel that could be used for aircraft, could be used in maritime shipping. But right now, if we generate hydrogen using fossil fuels, we have the same problem as if we generate hydrogen using, generate electricity using fossil fuels. But green hydrogen has a lot of promise. And the way that would work, if you've ever driven through the Permian Basin, you see all those, little nodding donkeys up and down, up and down. And then there's the flaring of methane. Instead of flaring that methane, if we had solar panels and wind turbines out there and it blows out there, and use that methane to generate hydrogen. The excess methane is CH4, 1 carbon and 4 hydrogen. That carbon that is the waste product would be pumped back down, and the hydrogen would be used as a fuel. That is a mechanism of storing that green energy, that wind and solar energy, for other uses. But again, if we made the cost of fossil fuel use equivalent to the damage that's caused, as economists propose, then other technologies, even technologies we don't know about yet, become economically feasible.
Stu, here's a question from David Stevens, one that I personally share. He asked, at what temperature rise will the permafrost methane be released? I am worried that the release of methane on a global scale will be a tipping point.
Okay, first, David, thank you, because I had forgotten to bring that up. I said I was going to revisit methane, and I didn't. I apologize. You're 100% correct. There is a significant quantity of methane that's trapped in permafrost. Not this past summer, the summer before, portions of Siberian permafrost were 38 degrees Celsius, 100 degrees Fahrenheit, kind of like an August day here. That's not what you expect, and that's not right. It's just not right. We're already beginning to degas methane, but the quantities of methane trapped in the permafrost are small compared to the quantities of methane that's trapped in the deep ocean. And the ocean is warming faster than the land. 90% of that excess heat is absorbed by the ocean. So there are things called, it's frozen methane. They're called methane clathrates. And they're buried in the sediment in the deep ocean. And if the ocean warms to the point where that's released, then it's all over. We will have a runaway greenhouse effect. Temperatures would rise to the point that would make destroy many, many ecosystems and make life, if survivable, intolerable. Direct answer, we're already beginning to lose that permafrost. But as you saw in that chart, if we're at 2 degrees, there's going to be significant permafrost degradation and methane release. That's why we have to keep it below 2 degrees.
Stu, we have another question from Helen Bryan, actually, and she says, we experienced snowvid in February. Is this part of global warming? Will we see more of this type of extreme weather patterns?
We kind of anticipated this question. Yeah, the short answer is the excursions of the jet stream and the polar vortex migration is normal. What's happening, however, is that it's exacerbated by climate change. And if Bill can bring up the slide, I'll show it to you. But on the left-hand side, we see the normal situation where we have a cold polar air mass and a jet stream. The jet stream kind of behaves like a wall that constrains that polar air mass, that cold polar air mass. And the strength of that jet stream is a function of the temperature differential between that polar region and the mid-latitudes, the south of them, basically where we are. What's been happening as a result of, oh, by the way, and that jet stream has a natural wiggle in it. In the northern hemisphere, there are land masses, North America, Europe, Asia, mountain ranges, the Rockies, the Himalayas, and that causes a perturbation in the jet stream that creates this natural wiggle. In the southern hemisphere, it's all ocean. So you have a jet stream in the southern hemisphere, but it tends not to wiggle. In the northern hemisphere and in the southern hemisphere, the strength of that jet stream is a function of the temperature difference between the polar regions and the non-polar regions. And what's been happening is that the polar regions have been warming, and they've been warming faster than any place else on the planet. That results in a smaller temperature differential, and that weakens the jet stream. And what we see on the right-hand side is the result of that weakened jet stream. That cold air mass can pour out of the polar regions down towards the mid-latitudes. And that's what happened in mid-February. That cold air mass sank because the strength of the jet stream, the structural integrity of that wall that the jet stream produces was degraded. So it's not a direct cause of climate change. It's exacerbated by climate change. Much as is the case with hurricanes. We're not going to see more hurricanes numerically. We're going to see stronger hurricanes, wetter hurricanes. So climate change has a multiplying effect, and it makes these extremes more extreme.
This question is from Terry Wood, and she says, quote, since 1.2 billion persons do not have access to heat, light, and mobility, as we do, how do you envision their energy pathway, and how do we assist or incentivize them? We don't want them to go down the coal fossil fuels pathway.
Right. I think it's clear that the poorest amongst us on this planet will suffer the most. And the humanitarian thing to do is to prevent that from happening. We all remember Fukushima, when a tidal wave devastated one of their nuclear generators. The nuclear power plant was destroyed, and the area is still radioactive. So the Japanese went up in arms and they wanted to get off of nuclear power. Japan is a volcanic island arc, and the most obvious clean energy source would be geothermal energy. Right here in San Antonio, the new Credit Human building downtown uses geothermal and solar energy. You know what Japan did? They went out to bid 13 new coal-fired power plants. They're sitting on an inexhaustible supply of clean, green energy. And they're going out for coal. And they're going out for coal because it is cheap. And again, that's where a global price on carbon comes in. Coal has the highest carbon density. The cost of coal would go up extraordinarily fast, and it would no longer be a viable source. So with respect to poorer nations, what we would need to do, and they're actually part of the Paris Agreement, is the establishment of a fund that the first world nations contribute to in order to allow these poorer nations to segue into a greener energy future. Many nations in Africa are going solar and wind rather than going down the fossil fuel path. It's something that takes leadership.
We have several other questions to address. The next one is from Mr. and Mrs. Stevens, not sure which one. They say, quote, I've heard the most immediate effective action we can take as individuals to change our appetite away from lamb and beef. Pork and chicken have less effect. Your thoughts?
Yeah, there was a webinar that Texas Tech University did just 2 weeks ago about this very topic. And yeah, cattle, beef consumption is bad for the environment. It's bad for the environment for two reasons. As a ruminant, it belches out methane. There's research that's being conducted to change their diet, and some promising studies suggest that feeding a certain type of seaweed reduces their methane production by 70 to 80%. But it's also responsible for a significant amount of deforestation, cutting down forests to create pasture. So yes, you're correct. Our diet makes a big difference. The advantage of a plant-based diet, and I'm not a vegetarian. I do eat meat, not often and not much, but I do eat meat. And I'm getting hungry right now. But the advantage of a plant-based diet is twofold. One, the plants themselves will be removing carbon dioxide from the atmosphere. The soils will be enriched by carbon dioxide and store carbon. The soils are an incredible reservoir of carbon. So encouraging an expansion of a plant-based diet is a good thing. Chickens and pork are less intense in terms of the climate impact, but more intense than a pure plant-based diet.
The next question.
Go ahead.
The next question also comes from the Stevens. Quote, I am a member of the San Antonio Interfaith Network. There is another national group called the Interfaith Power and Light that has two bodies, one being an educational group and the other being a lobbying group. The Texas group dissolved. There are many secular groups. My question is, they're one group steering climate resolution. How do we or should we become one voice? Philosophical question.
That's a very good question. CCL, by the way, has a branch, a religious outreach, a nuclear outreach, a business outreach, a gas and oil outreach, gas and oil ex-employees mostly. So yeah, the religious aspect of this is very important. We've talked to the Diane Dusenhoff and myself, and a few others have talked to the Catholic Diocese in San Antonio. We've done some work with them. How to get one voice? Boy, have I heard that a lot. That would be the answer to the outreach problem if we could just get one voice instead of having so many. Stuart, did you have thoughts?
Well, I wanted to ask Randy if it would be inappropriate to have Roger Ingersoll speak to that. Roger is our CCL representative who is, you'd have to explain it, Roger. You're in that religious outreach program. Would it be okay if he addressed it?
If he can do so in just a few minutes. We've got 8 minutes left before we have to sign off.
Can you unmute?
Roger?
Nope,
No.
maybe not.
Let's go to the next question.
Go
Then.
ahead.
Why are the polar regions warming faster?
That's a Stuart.
Another good question. Two reasons. Remember that first slide that had the sun's energy shining down on the earth? Well, a portion of that energy, a significant portion of that energy, is reflected back out, kind of like light bouncing off a mirror. When we have a polar region that has sea ice, so the ocean is frozen, and we have land ice, glaciers on land, that white surface reflects a tremendous amount of energy. But what's happening to these glaciers, because the ocean is warming, is that the ice, the sea ice, is melting from below. And as that sea ice melts, dark ocean water is exposed. And that dark ocean water absorbs more thermal energy, more heat, thus melting more sea ice. So the Arctic is warming because what's referred to as the albedo effect, the reflectivity of the Earth's surface, is reduced. With a high albedo, lots of snow, lots of sea ice, energy is reflected back out to space. But as we have more and more open water, more and more open ocean, that energy is absorbed. That melts more ice. More energy is absorbed. And you end up with this positive feedback loop that results in a warming polar region.
Another question having to do with the ocean from David Stevens. I've also heard that there is a risk of ocean currents slowing and huge damage of that happening.
Oh, yeah.
Yeah. There was an article in the New York Times just a week or so ago, an article in Nature, a science journal. Yeah, so in the late 50s, early 60s, oceanographic research was able to begin to get a handle on deep ocean currents. And we now know that there's something in the Atlantic referred to as a conveyor belt. Waters are from the tropics, the Gulf Stream, for example, move up north. Waters from the polar region move south and sink to create a bottom current. And the surface waters move across to Europe and then sink and come back down in this big loop. I'm trying not to get too sciencey here. These are called thermohaline currents. It's controlled by the water density. Thermo, heat, haline, salinity. The salinity plays an important role here. As we melt ice off of Greenland, fresh water is mixing with the salt water of the ocean. That changes salinity, changes its density, changes its behavior, and interferes with that thermohaline circulation, those deep water currents. If those deep water currents shut down, that's going to have a significant global climate impact. And we know what happens when there's an El Nino. We know that these deep ocean circulation patterns influence our weather. So yes, that's a reality. It's a threat, along with the threat of permafrost degradation and methane release. These are, again, reasons why that 1.5 degrees Celsius is such a critical temperature.
I think that movie Day After Tomorrow, which was like 20 years ago or something, 15 years ago, that addressed this current too. That was its main point.
Yeah.
So,
these are great questions. Keep them coming.
One final
I can do this
question.
all night.
It's 6:27 and we try to quit at 6:30.
Okay.
Hasn't all this warming occurred before in Earth's history? What's different now and what's the big deal?
Excellent question. I can do it in one word: rate. Climate change over Earth's history has taken millions of years to be manifested. That allows ecosystems to adapt, to evolve, and to respond. We are doing in decades what Earth's system, natural system, would do over thousands and thousands of years. So the issue is rate. Our ecosystem cannot, and we're part of that ecosystem, people, our ecosystem cannot respond quickly enough.
I think that has to do also with the confusion of smog with greenhouse gases, which I think is a very big deal in talking to a lot of people skeptical of what we're having here. Let me go to this one slide real quick and share this. There's an upper level and a lower level. The lower in 1963, I think we passed the first Clean Air Act, and that had to do with this smog. So a lot of cities around the world were getting different things that cleaned up the air, PM, particulate matter, and ground level ozone. But what we're talking about in climate change has to do with the upper level atmosphere, which is, it's global, it's not local. That was local problems. And very often people that said this has happened before, yes, it's happened before on a global scale, but like Stuart said, it's the rate. And so it's a different matter if you're thinking that the air is cleaner like here than it is in Beijing or India. That's local stuff, not global. Does that make sense?
Yes, indeed. Well, Bill, thank you. Stuart, thank you. This concludes our program for tonight. I'd like to tell our members that your slides and backup information are available. Stuart has said to just send him an email and he'll be happy to send you the slides if you'd like them, as well as the background information. A good program. We thank each of you for tuning in, and we'll try again in a few more months. Thank you so much for joining us today, ladies and gentlemen.